Good morning, HOD Professor A.K. Chaturvedi sir, my guide Hitesh Vijay sir, seminar coordinator D.P. Sharma sir, and faculty members, examiners, and my batchmates. I am Piyush Sharma, pursuing my Bachelor of Technology from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. Today I am here to present my seminar topic on stealth aircraft under the guidance of Sir Hitesh Vijay. So let's start with the first slide. These are topics of my seminar presentation. Firstly, we come to the introduction to stealth aircraft. Stealth aircraft are designed to avoid detection using a variety of technologies that reduce reflection or emission of radar, infrared, visible light, radio frequency spectrum, and audio, collectively known as stealth technology. The F-117 Nighthawk was the first operational aircraft specifically designed around stealth technology. While no aircraft is totally invisible to radar, stealth aircraft make it more difficult for conventional radar to detect or track the aircraft effectively, increasing the odds of an aircraft successfully avoiding detection by enemy radar or avoiding being successfully targeted by radar-guided weapons. Full-size stealth combat aircraft demonstrators have been flown by the United States in 1977, by the Russia in 2000, and the China in 2011. As of December 2020, the only combat-ready stealth aircraft in service are the Northrop Grumman B-2 Spirit 1997, the Lockheed Martin F-22 Raptor 2005, the Lockheed Martin F-35 Lightning II 2015, the Chengdu J-20 2017, and the Sukhoi 57 2020. With a number of other countries developing their own designs, there are also various aircraft with reduced detectability, either unintentionally or as a secondary feature. In the 1999 NATO bombing of Yugoslavia, two stealth aircraft were used by the United States, the veteran F-117 Nighthawk and the newly introduced B-2 Spirit strategic stealth bomber. The F-117 performed its usual role of striking precision high-value targets and performed well. Although one F-117 was shot down by a Serbian Reserve S-125 Naval Missile Brigade commanded by Colonel Joyton Denning. These are pictures of stealth aircraft. First picture Lockheed F-35S and F-117 Nighthawk, stealth and B-2 stealth bomber. Now we talk about the history of stealth aircraft. The existence of a new technology called stealth was announced by Secretary of Defense Harold Brown at the Pentagon News Conference in August 22, 1980. The special contribution of stealth was that it could reduce the radar cross-section of an aircraft to approximately that of a bird, enabling a bomber to penetrate deep into enemy airspace without being detected or intercepted. It is not too soon to say that by making existing air defense system essentially effective in effective, this alters the military balance significantly, Brown said. This is the design of stealth aircraft. The general design of a stealth aircraft is always aimed at reducing radar and thermal detection. It is the designer's top priority to satisfy the following conditions, which ultimately decide the success of the stealth aircraft. First point, reducing thermal emission from thrust, reducing radar detection by altering some general configuration, reducing radar detection when the aircraft opens its weapon spigot, reducing infrared and radar detection during adverse weather conditions. In the late 1950s, radar absorbing materials were incorporated into the design of otherwise conventionally designed aircraft. These materials had two purposes: to reduce the aircraft cross-section against specific threats and to isolate multiple antennas on aircraft to prevent crosstalk. The Lockheed U-2 reconnaissance airplane is the example of this category. By the 1960s, sufficient analytical knowledge had disseminated into the design community that the gross effects of different shapes and components could be assessed. It was quickly realized that the flat plate at right angles to an impinging radar wave has a very large radar signal and a cavity. Similarly located also has a large return. Thus, the inlet and exhaust systems of a jet aircraft would be expected to be dominant contributors to radar cross-section in the nose, on and tail on viewing directions, and the vertical tail dominates the side-on signature. Airplanes could now be designed with appropriate shaping and materials to reduce their radar cross-sections, but as good numerical design procedures were not available, it was unlikely that a completely balanced design would result. In other words, there was always likely to be a component that dominated the return in a particular direction. This was the era of the Lockheed SR-71 Blackbird. 10 years later, numerical methods were developed that allowed a quantitative assessment of contributions from different parts of the body. It was thus possible to design an aircraft with a balanced radar cross-section and to minimize the return from dominant scatters. This approach led to the design of the Lockheed F-117A and the Northrop B-2 stealth aircraft. Over the past 15 years, now 25, there has been continuous improvement in both analytical and experimental methods, particularly with respect to integration of shaping and materials. At the same time, the counter-stealth faction is developing an increasing understanding of its requirements, forcing the stealth community into the other round of improvements. The message is that with all the dramatic improvements of the last 2 decades, there is little evidence of leveling off in capability. This article consequently must be seen only as a snapshot in time. Now we are talking about the features of stealth aircraft. Absorption of radio waves. This is actually a very clear way of tackling radar absorbing material capable of absorbing electromagnetic waves are coated onto the surface of the aircraft. These coatings are made of composites which absorb the radio waves fall onto them, reflecting radio waves. This is primarily to be stealthy by designing the aircraft surface in a way that it deflects the incoming waves and scatters them in different conditions. Airframe shaped for low radar cross section (RCS), minimized engine noise, reduced infrared signature, reduced visual signature, non-metallic frame. Now we are talking about the working of an stealth aircraft. From the era of ninja assassins to the current one of fighter jets, stealth has remained a key tactic in combat. Today, though, sophisticated radar and heat sensing technology have made enemy vision a matter of more than just hiding in shadows. Most detection is performed with radar, a system that emits radio waves and analyzes the waves that bounce back in order to visualize objects. Stealth aircraft thus usually operates at subsonic speed, that is, speed less than that of sound, to avoid sonic boom. The B-2 Spirit, a strategic bomber of US, operates mostly at subsonic speeds. Newer aircraft such as F-22 Raptor, F-35 Lightning, Super 57, etc. are capable to operate both at subsonic and supersonic speeds. Now we are talking about the limitation of stealth aircraft. Sensors to locate target size, attack on ground targets, airborne laser radar in poor weather, vulnerability to visual detection in 10 miles, spatial maintenance, high costs, instability of design, aerodynamics limitations, electromagnetic emissions, vulnerable modes of flight, cost of operations. Stealth aircraft are typically more expensive to develop and manufacture. An example is the B-2 Spirit that is many times more expensive to manufacture and support than conventional bomber aircraft. The B-2 program cost the US Air Force almost $45 billion. Conclusion of the stealth aircraft is that the decreasing infrared signature caused by engine exhaust and other emissions from the aircraft should also be considered in maintaining stealth. However, no stealth aircraft are completely invisible to radar, with the fact that even the aircraft with the stealthiest abilities can be detected and tracked through low frequency radars. EMCA. We are talking about the EMCA program. The EMCA is envisioned as a twin-engine stealth aircraft with an internal weapons bay and the diverter-less supersonic intake. It will be a 25-ton aircraft with an internal payload of 1500 kg and an exterior payload of 55,000 kg, in addition of 6500 kg of internal fuel. The Indian Air Force is said to have committed to 40 AMC Mk-1 fighters and at least 100 Mk-2 derivatives as well as some unmanned variants. The AMC would be stealthy and have super cruise capabilities. Performance: maximum speed 2600 km per hour, maximum speed Mach 2.15, range 3240 km, combat range 1620 km. These are the references of my presentation, which is taken from different sites. Any question? Then please ask.
You talking about the AMCA, what does it stand for, and give some name of the stealth fighter jet in AMCA?
Yes. Advanced Medium Combat Aircraft is an Indian program to develop a stealth multi-role air superiority fighter for the Indian Air Force and the Indian Navy, which will also include 6th generation rocket technologies. First flight expected in 2024 to 25. The AMC is intended to replace the Spectre, Jaguar, Dassault Mirage 2000 and Mikoyan MiG-29 in the Indian Air Force. Thank you very much, everyone.